Okay, really quick, brief astronomy review for your test this week. Starting off with, you need to know that Venus is the hottest planet. Okay, it is the longest day, and the reason why it is the hottest planet is because it has an atmosphere, a thick atmosphere of carbon dioxide. It traps the heat in. Okay, and that heat never gets out of that thick atmosphere, and thereby Venus is hotter than Mercury. Okay, Mercury, closest to the sun, is a really, really hot side, but on its night side, there's no atmosphere to transmit that energy around to the other side. So you got like 400 degrees on one side and negative 180 on the other side. And that means that Mercury, on average, because there's no atmosphere to transmit the energy, is colder. And Venus, thick atmosphere, can transmit that energy all around it. Really, really hot. Hot enough to melt lead. So Venus, hottest planet, longest day. Longest day you can find in the reference tables on page 15. Next up, you need to know the cycle or the life cycle of a star, which is also can be found on page 15. Okay, it goes from a nebula, which is a giant cloud of gas, to a main sequence star, which is on the reference tables, then to a red giant, which is on or giant star. Okay, I just say red giant because that's the color typically of a giant star, and then a white dwarf. Okay, then we go to, you need to know that the universe is expanding because of redshift. That is, that the lengthening of, or the expansion of the universe is stretching out the rays of light to a redder spectrum of light, or a lower spectrum of light. So, redshift. Okay, it's just like the Doppler effect, but with light. Okay, and it's not the electromagnetic waves that are getting stretched. They're getting stretched because of space is expanding, which is kind of like a weird thing to think about. But it's still basically the same effect. It shifts to a lower spectrum of light, which is red, which electromagnetic spectrum can be found on page 14 in the reference tables. The other thing that goes along with redshift is cosmic microwave background. Okay, cosmic microwave background is basically the leftovers of the start of the universe. Okay, it's the static of the Big Bang. Okay, so two reasons we believe that the universe started with at least there was a start of the Big Bang. The two scientific facts would be redshift and cosmic microwave background. Okay, continuing, we have, you need to know your terrestrial versus Jovian planets. Okay, terrestrial are small, high density, rotation slow, and revolution fast. That means they go around the sun really fast. And Jovian are the gas giants. Okay, they're big, they're low density, have fast rotation, and revolve around the sun very slowly. We also need to know about stars. Stars upon the R's. Stars. Okay? The process is fusion. Nuclear fusion. Okay? What is fusion? It's the gluing of elements together. Okay? We also need to know that stars are made of hydrogen. Okay? Okay, that's the lightest element in the periodic table. Okay, periodic number 1. Okay, and let's see, the rest of the types of stars are on page 15 of the reference tables. Okay, so stars undergo fusion, and they fuse hydrogen together, and it becomes helium. Okay, next up. Okay, you need to know how to find flares. Here's the Big Dipper, okay, and we're looking for flares. We go off the 2 pointer stars right here, okay, and flares will be right there. We also need to know where we are in the galaxy, okay. We're in the galaxy right here. We're in the arm of the Milky Way galaxy. Okay, if we did a side view of the galaxy, okay, we wouldn't be in the disk, we'd be in the outs, and let's see, it's not quite the scale of the galaxy that's in that picture. It's a galactic bulge. We would be on the outskirts, okay? The outskirts of the galactic bulge and what's called the galactic disk, okay? So we're in the outskirts of the galaxy, and that's our location. Okay, so here's a diagram or a table of the 4 largest moons of Jupiter: Io, Europa, Ganymede, and Callisto. Okay, Galileo in 1610 found these moons. Now we're going to take a piece of the previous unit, heliocentric, geocentric, okay? And we talked about the fact that Galileo put some nails in the coffin for the geocentric theory by finding these moons. That's why they're called the Galilean moons. And these 4 moons going around another planet, okay, means that Jupiter was the object which they were going around. And that was a problem for the geocentric theory, because one of the base principle of the geocentric theory meant everything went around the Earth. And if Galileo finds 4 objects going around another object, the object being Jupiter, that was a problem. Okay? So that basically said, oh wow, there's another object in our heavens, in the sky, that has objects going around it. So that was problems for the sun, or I should say that was problems for the geocentric theory, okay? Because, again, objects are going around, not the Earth. Big problem. Okay. Io and Europa have a higher density. And if we look at their diameters, they're smaller, okay? Whereas Ganymede and Callisto have lower densities, and they have a larger diameter, okay? So what comparisons can we make to, because often it's said that Jupiter's a mini solar system, so you have 2 that are close to Jupiter that are small and are higher density, and you have 2 that are farther away from Jupiter and have a lower density and are bigger. There's some similarities there that we can place to our own solar system. The first 4 planets are closer to the sun and have a higher density. And the last 4 planets are farther away from the sun and have a lower density. So there's some parallels there, and that might be something to keep in mind for on your upcoming test. Okay, so that's a diagram that you might be seeing in the very near future. So I think that's about it for a review for our test. Okay, there'll also be some eccentricity questions there. Okay, you'll have to know when something's closer to the sun or closer to its planet, it's going faster. When it's farther away from the sun or farther away from its planet, it's going slower. And when it's closer, it's got greater gravity. When it's farther away from it, it's got less gravity. And that's about it. So I wish you guys good luck on your test next week, or this week.